Recording in progress. Yeah, we will continue practice the triangle congruency. Okay. We learned about this full theorem. Side, side, side. Side, angle, side. Okay. Make sure this angle is between these two sides. If you want to prove two triangle congruent, you want to make sure side, angle, side. If the angle was here, you cannot say this two triangle is congruent. The angle has to be between. The next one, angle, side, angle, angle, side, angle, okay? And angle, angle, side. Why the condition for angle, angle, side is not as strict as SAS? It is because the triangle interior angle summation is 180 degree. So as long as you know two angle corresponding equal, the third angle will for sure also corresponding equal. And then you have one side, it is good enough to prove the two triangle is congruent. We already show this counterexample saying SSA is not right because we have this triangle and this triangle showing here. This side congruent, this side congruent. These two angles also congruent, but you know these two are totally different. When we learned pre-calculus, okay, you will learn algebra 2 after geometry. You will learn pre-calculus after algebra 2. During pre-calculus, pre-P, we will learn about something called law of sine, okay? When we learn the trigonometry, we will learn law of sine. After we learn law of sine, we will truly understand why SSA is not working, okay? Some students may feel curious if AAA can prove two triangles to be congruent. Look at this. Triangle ABC and triangle A prime, B prime, C prime. These two angles congruent, this congruent. You know for sure the third one will also be congruent. But you are not given the side congruent. You cannot say this two triangle is congruent. But you see, these two look so similar. Yes, they are similar. They are called similar triangle. When we will learn triangle similarity, when you have two angles corresponding equal, this two triangle is called a similar triangle, and their common ratio will be the same. AB over A prime B prime equals to AC over A prime C prime equals to BC over B prime C prime, okay? This is the common ratio. This is not for triangle congruency. This is for triangle similarity, okay? I noticed that the students asked me something about the kite. So this is the kite, okay? For the kite, the property is you have this piece and this piece exactly congruent. If you want your kite to be able to fly, you have to make sure that you have the symmetric over this line, which means if you connect the diagonal, this is 90 degree, and you have this piece exactly equals this piece, and you have this piece exactly over this piece, then you can call this as a kite. If you don't make your kite exactly symmetric over this line, it's not going to be called as a kite, and it's not going to be able to fly, okay? Debbie, did this answer your question?
I just wanted to know which two angles were the pairs of consecutive congruence.
This two, you don't worry about that thing. This word make you feel confused. Ignore this, okay? Just know that this two congruent, this two congruent, that angle congruent to that angle. This is perpendicular. That's good enough. Don't worry about this word. Okay.
Thank you.
Okay. Yeah. I can also give you some trapezoid and kite worksheet. Okay. Yeah. So the kite property is saying this two piece equal, this two pieces equal, this two angle equal. Okay. But that doesn't make sure that this two plus together is 180. We don't have this property. It's no. Okay. You know, this two plus together plus this guy equals to 360. Why? Because this is two triangle. 180 plus 180 is 360. Okay. Yeah. For the kite, as long as you know this two piece congruent, this two piece congruent, this is perpendicular, that equal. That's all about kite. Okay. Now we need to go back to triangle congruency. Look at here. Abby. Let's see the first one.
They're congruent because side angle side.
Okay, side, angle, side. Very good. Each person do one row. Continue, Abby.
They are congruent because angle side angle.
Angle, side, angle. One more.
They are congruent because side angle side.
Yeah, this question here, they mark this congruent, that congruent, that congruent. You can say SAS. You can also say ASA. Okay, yeah. So you can use, sometimes you might have different ways to prove two triangle congruent as long as it is correct. Okay, yeah. So you can also say ASA, which is also good. That's good. Branson, number 4.
AAA.
Wait.
Oh wait, no.
Look. AAA is not to prove triangle congruent. AAA is to prove triangle similar.
Oh yeah.
We are looking for triangle congruency.
ASA.
This piece equal itself because
reflexive property.
Very good. Next one.
SSS. AS.
It didn't say anything. You say no conclusion.
Oh, okay.
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 That makes sense. Yeah.
Yeah.
You see none. There's no any conclusion based on that. You cannot say that two guys is congruent. Okay. Now Debbie.
Side angle side.
Okay. Side angle side. That's because of reflexive property. Okay. This one.
None.
You were not given enough information, even though the draw the graph makes this two looks like the same, but you cannot see it. Okay, yeah. So this is not. One more.
Side.
Yeah, side. By the time we learn the trigonometry, okay, or law of sine and law of cosine, yeah. For any triangle, you have 3 sides. You have 3 angles. We use the uppercase to represent the angle. We use the lowercase to represent the side length. Okay. Now I write down the law of sine right now. You will see this in 2 years. Okay. Sine A. Well, you say, teacher, I haven't learned sine A yet. we will learn about trigonometry, the basic trigonometry in geometry. Okay, we will learn about sine very soon. I want to write down the law of sine formula here. So by the time you learn pre-cal, pre-P, we will learn there are two rules. There are two laws. This is law of sine. And there's another law called law of cosine. You can copy down the formula first. This is called law of cosine. Okay. Now for the triangle, it has three sides. It has three angles. And there are so many interesting properties in just one triangle. And we also know the triangle area. The triangle area is the base times height, okay, divided by 2. Okay, after we learn the sine, cosine, we will be able to write down the triangle area by this. Okay, I know this is too much for you right now, but let's write down this. Then in 2 years, we will see this guy again. Next question. Abby, number 10.
Angle side, wait.
Side angle, but the side angle doesn't work, right?
Yes.
So we have to say none. Okay.
Oh, okay.
11.
Angle side.
Okay. Number 12.
Angle side angle.
Okay, very good. Branson.
ASA.
This one.
SAS. Wait.
Hold on. We learned about the right triangle congruency, right?
Yeah.
Yes. Okay. Let's revisit that. Look at this. For two triangle, if you know this leg congruent to this leg, this one congruent to this one, this is called LL, right?
Yeah.
Okay. And this one, you were given a hypotenuse congruent, and you were given one of the angle congruent. These two will be congruent based on HA. This is hypotenuse, is an angle, you call it HA. Remember?
Yeah.
Okay, yeah, I think, let's do this. Look at this. So I can rewrite this question. Two leg congruent. Correct?
Yeah.
Two leg congruent. If two leg congruent, you want to prove this two triangle is congruent, what theorem you use?
Pythagorean theorem.
You can prove that this piece equals this piece by Pythagorean theorem. Or you can just say SAS, correct?
Yeah.
And you know that angle C congruent to angle C prime congruent equals to, because this is because right angle are congruent. Okay.
Okay.
And these three together tells you triangle ABC congruent to A prime, B prime, C prime, right? Yes. And
Yeah.
this is called SAS, right?
Yeah.
Okay. Now, Debbie, I'm going to mark the point here. We were given the hypotenuse congruent. And we were given angle A. Okay. And we also know that the angle C is congruent to angle C prime. Same reason, right angle are congruent. What we use to prove these two congruent by what?
Triangle ABC is congruent to prime triangle ABC because of angle side.
Because angle side AAS, very good. Okay, very good. Look, after you prove these two triangle congruent, you can use L as a new theorem when you have two triangle, right triangle, okay? So those one which you already proved can be used as a new theorem to prove later on. So for this one, you were given these two congruent, that congruent. Now you prove these two congruent. So you call this guy HA. HA can prove two right triangle congruent. This is LL, this is HA. Now we want to see the LA. Okay, Abby. Let's see this one. You have this angle congruent, and you have this leg congruent. What you want, which theorem you want to use to prove this to be congruent?
ASA.
ASA. Okay, so by using ASA, you can prove this two triangle congruent. And you can also say, as long as I have a LA, it's going to make two right triangle congruent. Okay, so ASA to prove LA is working. Some students may feel curious. Teacher, you put your angle here, that might be right. What will happen if you have the angle on this location? Let's see here. We get here congruent. We got this two triangle congruent, this two angle congruent, this angle. We can also use AAS, right? AAS can also prove, right? Correct, Abby?
Yes.
Angle side. Okay, yeah, Abby, let's do one more. Given a hypotenuse congruent, given a leg congruent, how do we prove these two are congruent? SSA is not working. What can we do? In right triangle, what else do we have?
A right angle.
Yes, so Does the Pythagorean theorem work?
Yes.
AB squared equals
Eight.
BC squared plus AC squared, right?
Yes.
Same thing for A prime, B prime, right?
Yes.
Okay. Now look at this. These two congruent. These two congruent. Yeah, you were given the hypotenuse congruent and AC A prime C prime congruent. So does these two congruent?
Yes.
Okay, these two congruent. So BC congruent to B prime C prime. Now we prove this piece also congruent. Then we use what?
Side.
Yeah, and then we use SSS to prove this two triangle is congruent. After we use this to prove that two congruent, we can also say HL also work, okay? So I want everybody, please remember this four. Leg, angle. Oh, this is not Los Angeles. This is leg angle. HL, HA, okay? This four. Okay. Let's take a look at these questions. Branson.
Wait, so what do you want me to do?
I want you to tell me which one.
Oh, HL.
HL. Good. One more.
HA. Wait.
No. You know these are the same.
Oh.
Look, for the right triangle, this is called the leg. This is called the leg. Okay. So HL. Make sense?
Oh yeah.
H hypotenuse equal, leg equal. So HL. Okay.
Okay.
One more.
LA.
Leg angle. Very good. Okay. Now Debbie. Number 4.
Leg LA.
This is leg because this is the 90 degree. You have an angle equal, so this is LA. Okay, very good. How about this one? What does this mean?
The base angles equal.
This guy is isosceles. This guy. Okay, so JL. They said this guy is the isosceles triangle. That means this piece equals this piece. This angle equals this angle, right?
Mm-hmm.
And they also say that is 90 degree, right?
Mm-hmm.
Okay. Now, they also give you information saying this angle equals this angle, okay? Yeah.
Mm-hmm. Mm-hmm.
And you want to prove this guy is congruent to this guy by what?
HA.
You know this is congruent based on the isosceles definition.
Mhm.
And you also know this two angle equal. So this is called a hypotenuse angle, HA. Okay, very good. Now next one. They want to
LA.
put, this is one leg.
Wait, LL. LL.
LL. Okay, that's all. Definition of midpoint makes this two congruent. Okay, very good. Now we are coming back to the proof questions. Let's see here. It's too squishy here, okay? I'm going to move this guy to the next page. Abby, let's prove this together. You want to use flowchart or you want to use two-way columns?
Flow chart. Given line EB is congruent to line DB.
Okay.
Given angle A and angle C are right angles.
Next.
Given B is the midpoint of line AC.
Okay. Next.
Angle BEA is congruent to, triangle BEA is congruent to triangle BDC because of LL. HL.
Yeah. Hold on. We need to write an extra step, okay?
A line AB is congruent to line CB. By definition of midpoint.
Let's write down this one more step. We see angle ABE and the triangle CBD are right triangle, okay? Make sense?
Yes.
Okay. And then we can move this guy down here. Okay. Now we can prove. We write down BEA, BDC. We want to put them corresponding equal, okay? And we want to write down here as what?
HL.
HL. This is hold on. This is the angle, and this is the leg, right?
Yes.
And this is the hypotenuse, okay? HL. Okay, that's how. Okay, very good. Let's see one more question. Present.
Um,
Yeah, you want to use which way?
flow chart.
Okay, go ahead.
Given line AB is perpendicular to lines CM.
Okay, next.
Given line AB is perpendicular to line DB.
Okay.
M is the midpoint of line AB.
Okay.
And then wait. Definition of midpoint AM is congruent to MB.
Okay. Next.
Line CM is congruent to line DB.
Correct. Makes sense.
Yeah.
Okay. And we want to write down one more step. Okay. And we can say triangle AMC is right triangle. Okay.
Okay.
And then MDB. Okay. Okay. Next. Go ahead.
Wait.
Triangle.
Triangle AMC is congruent to MBD.
By
Wait. Is it HL?
this is.
Oh wait, no.
This is one leg. This is another leg.
Oh, LL.
LL. Okay. Now you might wonder why I have to write down this. Look, all the four theorem we proved just now, all of this standing on the basics that the triangle are right triangle. If you don't have a right triangle, you cannot talk about the LL, HA, LA, and HL. Okay. So anytime when you want to use this full theorem, HL, LL, HA, LA, you have to mention that the two triangles are right triangle. Otherwise, you cannot use those things. That's why we want to write down over the flow chart. Okay. Make sense?
Yeah.
Okay. Well, you can Those questions are not hard. You can try finish all those by yourself. I want to focus on the proof part, okay? Now let's see here. Let's see an example here. We have to come back to the two-way columns proof. Debbie,
Mm-hmm.
let's see here.
Um,
This piece equals this piece.
Mm-hmm. Given AD is congruent to line AB,
Given, right?
mm-hmm.
Next.
Given line AC bisects angle DAB,
Given.
angle DAC is congruent to angle BAC.
Okay.
Angle bisector.
Definition.
Oh, definition.
Next.
Line AC is congruent to line AC reflexive property.
Next.
Triangle ADC is congruent to triangle ABC side angle side.
Okay, very good. Now, if I want to prove one more step. I want to mention that angle D is congruent to angle B. If I say angle D is congruent to angle B, what should I write down here?
CPCTC,
Stands for?
corresponding parts of congruent triangles are congruent.
Yeah, perfect. Very good. You mastered all of this. Nice. Abby, let's do number 9.
Line AB is congruent to CD given. D is the midpoint of line BE. Given. Line BD is congruent to line ED. Definition of midpoint.
Next.
Line AB is congruent to line CD.
We already mentioned, right?
Oh, sorry, parallel.
Okay.
and angle B is equal to angle D congruent.
Be careful. This angle you can call angle B, no problem. This angle you cannot say angle D. So
Angle CDE.
yeah, let's change some purpose. Okay. Next.
Because corresponding angle postulate.
Mhm. Okay.
Triangle ABD is congruent to triangle CDE because of side angle side.
Okay. Okay. Perfect. Very good. Yeah. We just want to make sure when you call the angle here, if from one point you have multiple lines, not just two lines, you want to make sure you do this to name the angle. Okay.
Yeah. Okay.
Now let's see here. Branson. Okay, number 7. What do you call this?
HL.
Did I say
Wait.
this is 90 degree?
Oh,
If I mark this, that's 90 degree, but this is not 90 degree, right?
oh yeah.
Okay. So what you have to do? This is SSA. SSA is not working, right?
Yeah.
So what you can do?
Wait.
You say 9, right?
Oh yeah.
Okay. SSA is not working. It cannot be used as a theorem. So you can say 9. How about this one?
SAS.
Okay, SAS. Very good. One more.
SSS.
Yes, SSS. Very good. How about this one?
SAS.
SAS, really?
Wait.
Hold
wait.
on. Hold on. Be careful. Maybe these two equal. This is SSA, not working. But when they mark this, that means these two lines are parallel. Okay? If that
Okay.
two lines parallel, then the alternate interior angle equal. That's why you call it SAS. Okay?
Okay.
Okay. Very good. Make sense for you now?
Yeah.
Mhm. These two congruent not because of SSA. SSA is not working. These two congruent based on these two lines marked as parallel. As parallel lines, the alternate interior angle equal. You can also see this angle equal. So this is called SAS. Okay, SAS. Debbie. Number 3. The graph show you these two congruent. This angle congruent. This side congruent. Okay. So
Sorry, I think my mic had side angle side.
yeah, side angle side. Very good. How about this one? How about this one?
My mic keeps breaking.
Oh.
Is it side? Wait, no, none.
Not. This is not. This is side angle. Side angle is not working. You cannot use that. Okay. How about this one? SAS. Yeah, your mic probably doesn't work again. And the last one is side. Okay.
Side.
Yes. Okay. Okay. Now let's continue with more proof. Abby. Let's try number 6.
Obvious. Get reason number 1 is given.
Okay.
Reason number 2 is definition of midpoint. Number 3 is a vertical angle postulate. Number 4 is definition of midpoint.
Okay.
Number 5 is SAS.
Okay, very good. Now, Branson, look at number 5.
Given given definition of angle bisector.
Very good. Okay,
Reflexive property.
nice. Last one.
SAS.
So we prove that this congruent, reflexive, this congruent, and also the angle. Okay, this is supported by SAS. Okay, very good. Yeah, I think all the other questions you can handle it. It's not so that hard. Okay, yeah. Let's come back to this. Let's see here. Hey, Debbie. Let's see.
Hello.
Mhm.
Okay, I was just checking my mic. AD. So angle BAD and angle CAD is congruent.
Okay.
And then BA and line CA is congruent.
Okay.
AD is congruent to AD. So triangle BAD is congruent to triangle CAD by SAS.
Okay, very good. 23.
Line WU is congruent to line UV. Line WY is congruent to line XV. And then line YUW is, angle YUW is congruent to XVU. Angle VUX.
Look. We also have
Oh.
this.
Line YU is congruent to line UX.
Yes.
So triangle WUY is congruent to triangle XUV.
And W is corresponding to this, yes?
Oh, yes.
You see,
VUX.
the opposite, the congruent side, opposite angle. Okay, so we want to see V first.
Okay.
And then we
VUX.
say U. Okay, by what?
Side angle side and side side side.
Yeah, we can say SSA. Oh, sorry, not SSA. SAS. Oh, SSS, right? Okay, very good. Now, Abby. Let's see, 20.
Line JN is congruent to MN. Line JK is congruent to MK. Triangle JNK is congruent to triangle MNK by side, side, side.
So you said J and K is congruent to what?
MNK.
Very good. M and K. Okay. Okay. SSS. Okay. 21.
Line FP is congruent to line HP. Angle F is congruent to angle H. Triangle PFS is congruent to triangle PHR by angle side angle.
Hold on. I want you to tell me one more condition makes this two triangle congruent. You have here, you have here. What else you have?
Angle FPS is congruent to angle HPR.
Very good.
Angle P is congruent to angle P by reflexive property.
Okay, yeah. Now you want to give conclusion of?
Triangle PFS is congruent to triangle PHR by angle side angle.
Angle, side angle, angle, side angle. Okay, yeah, very good. Next one. Branson. Let's look at 19.
D is the midpoint of line MT. So MD is congruent to DT. angle MDB is wait, oh, angle MDB and angle T are right angles,
Uh-huh.
and line BD is congruent to ZT. So triangle MDB is congruent to DTZ by SAS.
MDB DTZ. Who else you can use here?
SSS.
Mm,
Wait, what?
this is the right triangle. Who else you can use? HLLL HALA.
Oh, LL.
Yes, LL, that's right. Okay, very good. Debbie, let's look at the number 18.
Okay. Angle TVU is congruent to angle WUV.
TVU. Okay.
Line VT is congruent to line UW. Line VU is congruent to line VU.
Okay.
So triangle TUV is congruent to triangle WVU.
T is this guy. So you are looking for W. You want to put W. TUV. So WVU. Okay. Some people got confused. People say, this is V, this is V, this is U, this is U. No, you are talking about the angle between. You want to make this angle congruent to that angle. So V is corresponding to U. And you want to make that angle congruent to that angle. So U is corresponding to V, right?
Mm-hmm.
Yes. And here equals here. Okay. Yeah. By,
Yes.
sure. By what?
Side angle side.
Yes. Okay. Very good. Abby, let's do the last one.
E is the midpoint of line KW, so line KE is equal to W. Angle KEG is congruent to angle W. Shouldn't it be another angle?
So what else?
Angle KEG is congruent to angle WEH.
Okay.
Triangle KEG is congruent to triangle WEH.
Okay.
By angle side angle.
The KEG WEH angle side angle. Okay. We want to have the habit of putting the point correspondingly equal. This is the critically important when we are going to learn the similarity. Okay. Yeah. So let me show you. We are going to learn the triangle similarity very soon. For the triangle similarity, we are going to do those ratios. Okay, we are going to come back to some question like that. This is the beginning for review the algebra foundation. After we go through those foundations, we are going to do those real calculations. So we have to have the habit to look, this one. If you want to calculate the x value here, they told you this MNP QRP. Okay, so you do this over this equals to this guy over this guy equals this guy over this guy. If you do the wrong pair, this divided by this equals this divided by this, totally mess up. Okay, yeah, we want to have the habit to put them in the right order. I'm going to upload the homework now. Geometry, the first semester is not hard at all, but the second part, they will combine a lot of algebra knowledge with geometry. It's going to become harder, okay? Yeah, that's for today's class. I will upload the video and I'll see you next week. Okay, bye-bye. Have a happy July 4, okay?
Thank you.
Okay, bye-bye.
Thank you.
Thank you, you too.